Deck, let's launch the RV.
So the deep sea spans from 200 meters all the way down to 10,000 meters. And the deep sea is very dark and very cold. The types of animals in the deep sea is just amazingly vast. We don't even understand how many animals are actually living in these deep sea environments. It's so understudied. But the types of animals you'll see are going to range from sea cucumbers to corals to sponges to different types of fishes, sharks and rays, crabs, shrimps, you name it. If you've seen it in the shallow, there's probably a deep sea cousin.
Oh, come on. Oh, so close.
He looks hungry.
He did look hungry.
Every organism has a way to sense its surroundings and interact with its environment. And these animals usually interact by things like touch and smell and some types of sight. So there are different levels to these types of senses that each animal possesses, and that's what makes studying these animals really interesting, because they are similar in ways to us, but also very different in how they've found solutions to the problems of how do we interact with their environment and with others around us. When you're a sessile animal and you can't move place to place, how do you tell your neighbor or your far-off neighbor what's going on? You want to reproduce with others of your kind, but you can't sense them or see them in any way. A lot of these animals will put off types of olfactory-related particles into the water column so that other animals can sense it. And a lot of animals, even on land, do this, which is how different animals, even when they're not visible to each other, can sense when it's time to reproduce. It's a way to signal to each other. It's all about signaling and communication. And how do you communicate without words? And smell is one of the strongest ways that animals communicate without words.
We think of sound as a primary way that marine animals learn about the world around them. It's a way that marine animals communicate, navigate, orient, detect predators, avoid predation. We think of sound traveling 5 times faster in water than it does in air. So that means that animals can communicate over relatively long distances, or they might be able to hear really faint sounds from a good distance away. It becomes this really adaptable way that they can use to communicate. A shallow water environment, like a coral reef, might be kind of Grand Central Station, where it's really noisy, really vibrant, a lot of activity going on there. And if you're just making a few sounds, it's harder for your predator to hear you. But if you make those sounds in the deep sea, it's quieter, and you're kind of like, walking through that silent forest, and it's easier to hear that mouse moving along the leaves. And so it's a quieter environment at depth. If it's a relatively quiet environment, maybe you don't want to make a lot of noise, because it makes it easier for that dolphin or whale or that other fish to detect you and eat you. One of the things we know is animals like squid, they might have something what we kind of think of as acoustic crypsis. So they're somewhat acoustically transparent, or they're a little bit hard for these echolocating animals to detect. The idea is to be similar density to water, so you're a little bit hard for that echolocation signal to bounce off of.
It's got something in its eye.
Yeah, what's up with the fish down here?
These animals living in the deepest depths of the ocean don't resolve images in the same way we do. Generally, their eyes are used for light detection rather than being able to see the world in full color. The amount of light is so little. That's why these animals have such large eyes, because the larger your eye, the more photons can hit that back of the retina and be able to be detected. Some animals have modified eyes, like the Ipnops fish. You usually see that laying on the seafloor. It has a sort of concave eye plates, and those are just for light detection. And they're ambush predators, so they might be detecting that light and using it to hone in on potential prey. All of the light, besides our ROV, is produced by bioluminescence. Bioluminescence is produced by a number of different types of animals for many different reasons. The bamboo coral will light up in bioluminescent flares, and this will bring attention to the coral so that top predators like your rat tails comes and consumes the animal that was potentially consuming that coral.
Whoa, okay, you can just see beautiful imagery of D2 approaching this large field of tree-shaped corals.
Corals and sponges definitely react to touch. And this can include physical touches by other animals, or also physical touches by objects, and changes in water pressure through currents. And these senses are activated by cells within their membranes. So in the same way that we feel touch on our skin, these animals feel touch on their tissues as well. Generally, when they're in a feeding posture, they have their polyps out in the water column, trying to collect particles for feeding. If something like a fish swims by, the coral will retract its polyp because it doesn't want to get fed on by a predator. And a lot of other animals and plants do have this same reaction when touched, is to pull in and be safe.
There's a lot of really interesting stuff in the deep sea, and every time we dive, we almost always see something new and definitely something exciting. Sort of goes to show how little we know and how much there is to learn.